Hello students, welcome to this crash course in which we are covering the topics of different engineering entrance examination, mostly focusing IIT JEE, both mains and advanced, right? So note that this is a crash course, so you all, that is students, are expected to have some knowledge, previous knowledge of these topics which we are going to discuss, and here we will be mostly focusing on problem, that is this crash course is mostly problem oriented rather than discussing the whole theory in detail, right? Okay, so today we are starting coordinate geometry. This is very important topic in most of the engineering entrance examination, right? And the most important thing is one can assume 100% success in this. So you will be able to solve each and every problem in your engineering entrance examination which are related to coordinate geometry. That can be assured. So let's have some revision of theory. We will not go into much detail. Okay, so first of all, distance formula. Okay, distance formula is used to calculate the distance between 2 points A and B, okay, whose coordinates are x1, y1, point B coordinate is x2, y2, and so we will have the distance d as x1 minus x2 square plus y1 minus y2 square under root. Okay, similarly we have section formula. Okay, section formula is used to calculate the coordinate of a point, third point, which divides the line AB internally or externally in some ratio. Say suppose point C is dividing this line internally in ratio lambda 1 is to lambda 2, and coordinate of point A is x1, y1, B is x2, y2, and the coordinate of point C is xy. Okay, so we can calculate x with the help of this. X is equal to lambda 2 x1 plus lambda 1 x2 upon lambda 1 plus lambda 2. Similarly, y can be calculated by lambda 2 y1 plus lambda 1 y2 upon lambda 1 plus lambda 2. See, this point C is dividing this line AB internally, that is point C lies on line AB. Okay, by the mean internal division we mean C lies on line AB. Now if there is an external division, that is if a point C is dividing externally, okay, is dividing externally by mean we have to extend the line AB, that is here is point A, here is point B, and say here is point C. So point C is actually dividing this line AB externally. So point C is external to line AB, line segment AB. So we have the ratio this lambda 1 and this lambda 2. Okay, that is AC upon BC is equal to lambda 1 upon lambda 2. So in case of external division, if we have to calculate x and y, so in place of plus we will be using minus sign. Okay, similarly lambda 2 y1 minus lambda 1 y2 upon lambda 1 plus lambda 2, right? Okay, so this is the section formula. Using this formula we can calculate the coordinate of point xy. Okay, this coordinate, if coordinates of point x1 y1 and x2 y2 is known, or you can also calculate, if these two are known, you can also calculate this, or you can also calculate the ratios of point if these 3 points are given. Okay, all the three variables, or this ratio can be calculated using this section formula. You all have used this section formula for solving many problems. Okay, so after this, say suppose the third is area of triangle. Let's have a look on that. Area of triangle. Area of triangle. Area of triangle. So triangle means we have three vertices. Okay, say let's name these vertices as A, coordinate x1 y1, B x2 y2, and C x3 y3. Okay, so for a triangle to be made, these 3 points must not be collinear. Okay, so non-collinear, A, B, C are non-collinear points. That is, these cannot be lie on a straight line. This should not be lie on a straight line. Okay, A, B, C must not be collinear points. Okay, so we have area of triangle as, let's denote the area of triangle. Area of triangle ABC is equal to the half of the value of determinant x1 y1 1, x2 y2 1, and x3 y3 1. Okay, I hope you all know how to evaluate this determinant. So we can calculate the area of triangle using by expanding this determinant, in which the elements are the coordinates of A, B, and C. Okay, so from here we can calculate the area of triangle. Now let's have some look on the different issues in geometries. Like there are different points like centroid, incenter, orthocenter, circumcenter, excenter. So let's have an idea what are those points. So first let me introduce centroid of a triangle. Let me introduce a symbol which must be familiar to you. We will be using symbol like, say this is a triangle ABC. So opposite to vertex A, we will be having side length A. Okay, opposite to vertex B, we will be having side length small b, and opposite to vertex C, we will be having side length small c. Okay, so this symbol we will be using throughout the course. Okay, so what is the centroid of a triangle? So centroid is a point of intersection of medians of a triangle, where medians of a triangle, point of concurrency of the medians of a triangle. Concurrency means where more than two straight lines meet. Okay, so median of a triangle, that is midpoint, line joining vertex to the midpoint of opposite side. So this is a vertex and midpoint of this side is, say, this D. Okay, so line joining this CD is a median. Okay, similarly say line joining, this is the midpoint, say we denote this midpoint by E, so AE is a median. And similarly, if we denote a midpoint of AC by F, then FB is also a median. Okay, and this can be proved that these all three medians are concurrent, and this is known as centroid. So let us denote this centroid by G. Okay, so G is called the centroid of a triangle. So if we know the coordinate of vertices, that is x1 y1, x2 y2, and x3 y3, so we can easily calculate the centroid G. XY. Okay, so x is equal to x1 plus x2 plus x3 upon 3, and y is equal to y1 plus y2 plus y3 upon 3. Okay, so centroid can be easily calculated using the coordinates of vertices A, B, and C. This formula can be derived using section formula, because we all know that centroid divides the median in the ratio 2:1. So first you will be calculating this coordinates of point D, because this is the midpoint. So this is 1:1. You can calculate the coordinate of point D, and since you know the coordinate of point C as well as D, and you know the ratio, so you can calculate the coordinate of point G. So this you will be getting after calculation. So we can calculate the centroid of a triangle. So after centroid, let's move towards incenter. Incenter, okay. So incenter is a point of concurrence of angle bisectors of a triangle. So this is A, this is B, this is C, and this is side A. Again, this is side B, and this is side C. So this is an angle bisector, and this is another angle bisector. So point of concurrency of all three angle bisectors. Angle bisectors means this angle is equal to this angle. Similarly, this angle is equal to this angle, and this angle is equal to this angle. So all three angle bisectors meet at a point which is called incenter of a triangle. Okay, and this incenter has a very unique property, that its distance with all these three sides are equal. That is, if we draw perpendiculars to all three sides from this point incenter, then the length of perpendicular are equal. That is, all these three lengths are equal. That means that if we take a radius equivalent to this length and put an arc over here, then we can draw a circle which will be touching all three sides, and this circle is known as incircle. Okay, incircle. I hope you are all familiar with this incircle. So and this let's denote this radius by small r. So this small r is in radius of this incircle. So if we want to calculate the coordinate of incenter I, say XY, so again coordinate of I can be written as in terms of coordinates of x1 y1, that is coordinates of point A, B, C, x2 y2, and the length of side x3 y3. So x is equal to A x1 plus B x2 plus C x3 upon A plus B plus C, and y is equal to A x2 plus B, here it should be y2, A y1 plus B y2 plus C y3 upon A plus B plus C. Okay, this A is the length of vertex, is the length of side opposite to the vertex A. Similarly, B, small b, is the length of side opposite to the vertex B. So we will be, while applying this formula, you have to take care of that. Okay, so after incenter, let's have a look of Excenter. What is Excenter and how we are going to calculate, what is the formula from which we can find the Excenter. We have a triangle A, B, C. Okay, so Excenter is a point of concurrence of two external angle bisector and one internal angle bisector. So what is the meaning of external angle bisector? So if we extend the side of a triangle, say we are extending this side and this side, then we have external angle as this. So this is the external angle bisector of this triangle, and similarly here we have one more external angle bisector. Say this is also an external angle bisector. This angle is equal to this angle. Similarly here also this angle is equal to this angle, and one internal angle bisector, that is this opposite to this side. This is angle bisector of this angle A. Okay, so this point is the Excenter. Let's name it as E1 because we have three. We will be having three Excenter. One here, and one here. E1, E2, and E3. Right? Because there is also an angle bisector here also. Extending this side. And angle bisector of this. So E1, E2, and E3 similarly. And if we take this as a radius and draw a circle by putting an arc here, so this will be touching all these three sides, two sides externally and one side internally, right? So X circle. So these three, we can draw three X circles. Okay. This touching this point, this is X circle, three X circles. Okay, so if we want to write, let me write the formula for Excenter. X1 y1, x2 y2, and x3 y3. And this is side A, this is side B, side length B, and this is side length C. Okay. So E1, x1y, let me name as xy, xy. Okay. So this x will be, this is, note that this is opposite to vertex A. So x will be minus ax1 plus by1 plus, here it should be x2, bx2 plus cx3 upon minus a plus b plus c. Okay, and similarly y is equal to minus a y1 plus b y2 plus c y3 upon a plus b plus c. Okay, so if we have to calculate the Excenter here, that is opposite to vertex B, then instead of minus a we will be writing minus b, and here a x1 minus b x2 plus c x3, and in denominator a minus b plus c. Okay, and E3 will be a x1 plus b x2 minus c x3, and here y coordinate is a y1 plus b y2 minus c y3, and similarly denominator will be a plus b minus c. Okay, I hope you all understand this Excenter. Okay, after this there are two more points. That is Circumcenter, and orthocenter. Okay, we will not be giving formulas for calculating Circumcenter and orthocenter. We will be calculating it while after reading the straight line, after having the theories in straight line. Okay, so Circumcenter is a point inside a triangle ABC. Okay. Circumcenter is the point of concurrency of perpendicular bisectors. So we have three perpendicular bisectors of sides. This side A, this is a perpendicular bisector. That means it is dividing this side AB in a ratio 1:1, that is equal division of side AB, and also it is dividing it perpendicularly. So this is perpendicular bisector, this is another perpendicular bisector, this is equal to this, and this is another perpendicular bisector. These are the perpendicular bisectors of three sides, which is concurrent at a point known as Circumcenter. Okay, so Circumcenter is the point of concurrency of perpendicular bisectors. Okay, orthocenter is a point of concurrency of altitudes of a triangle. Okay, say this is ABC triangle. So altitude means from this vertex we have to draw perpendicular on opposite side. So this A, let us name it as D. AD is an altitude. Similarly, if this is E, CE is an altitude, and if this is F, then this BF is an altitude. So these altitudes are also concurrent at a point known as orthocenter. So we can also calculate this circumcenter and orthocenter, okay, in terms of sides and the coordinates of the vertices. Okay, so these are the points which are related to triangles. Okay, so now moving forward and introducing the concept of locus of a triangle, locus of a point, sorry, locus of a point. So what is the locus of a point? See, locus of a point is a geometry, is a shape, okay, which a point follow by say, for example, if I say a point moves in such a way that its distance from two fixed points are equal, that is, two fixed points are equal, same or equal. Okay, so we have two fixed points here and here. Let's have two fixed points, A and B, and a moving point, say C. C is a moving point which is equidistant from this point A and B both, and C is a moving point. C is not a fixed point, so C can be here, either here or here, okay, anywhere on this line. Okay, so C will be moving like this, okay, on this line. So C will have a geometry, this point will have a geometry. If this point moves, then this point will have a geometry like this. Okay, so this is the locus of this moving point C. So locus of moving point is a geometry. So this straight line gives the locus of this moving point. Okay, so this straight line is the locus of moving point, and the condition applied to this locus is it always maintain equidistance from this both point A and B. Anywhere if you take, this distance will be equal to this distance. So this line is actually the perpendicular bisector of this line segment AB. Okay, similarly, if a point travels in such a way that it always have a fixed distance from a single point, then a moving point travels in such a way that have fixed distance, maintains fixed distance from a fixed point. So what is its locus? That is, what is the locus of moving point? So let's have a fixed point alpha beta, okay, and a moving point, say XY. So this point moves in such a way that it always maintains equidistance from this point. So we will have the locus like this, right? So the locus is a circle. We all know that this distance in a circle, any point on circumference have equal distance from its center, right? So this moving point will form a geometry of a circle, okay, right? In coordinate geometry, we write expression in algebra and we think of geometry. Okay, so we have to relate this as an algebraic expression. So let's have this distance as r. So we have this distance r. So what is the distance between these 2 points? Say if this point is xy and this point is alpha beta. So we have r as x minus alpha square plus y minus beta square under root. So this is the equation of a circle, right? Isn't it? X minus alpha square plus y minus beta square is equal to r square. Okay. So this locus, this algebraic expression gives the equation of a circle, which is the locus of a point, this moving point in this condition. Okay. So let us have an illustration on a locus of a point. So the ends of a rod of length L, the ends of a rod of length L move on two mutually perpendicular lines. Find the locus of a point on the rod which divides it in the ratio 2:1. So let us have a two perpendicular lines, and ends of a rod of length L move on to this line. So say this is a rod of length L which is moving on this line. So this rod is like this. Now if it moves some distance below, then it is like this. Okay, but this length is fixed. Note that this length is fixed. This can be like this, okay, or this can be like this, right? So this can be the position of rod of length L. Okay, so we have to find the locus of a point on this rod which divides it in ratio 2:1. So say suppose if rod is here, then a point which divides it in ratio 2:1 is somewhat here. Okay, and if rod is this, okay, this is a point which is dividing the rod in the ratio 2:1. So here the point is this, here the point is this, here the point is this something. So we have some kind of geometry, right? That is the locus of a point. Okay, so rod is moving and this point is also hence moving. So we have to find that geometry, that expression which relate that geometry. Okay, so let's begin. So let's take these two perpendicular line as x-axis and y-axis in coordinate. Okay, and we have a rod. Let us take this point as A0 and this point as B0, and this length of a rod is fixed, which is L. Okay, and we have a point P which divides it in ratio 2:1. Okay, so coordinate of point P, let us have the coordinate of point P as h and k. So h must be 2 times a plus 0 times b upon 2 plus 1, that is 2a upon 3, and k is equal to 2 times 0 plus 1 times b upon 2 plus 1, that is b upon 3. So we have h and k, or we can write a as 3h upon 2 and b as 3k, right? So we will also, from the relation that L is constant, we have a square plus b square is equal to L square. So we can write a as 3h upon 2 and b as 3k. So substituting the value of a, that is 3h upon 2 square, and b as 3k square is equal to L square, that is 9h square upon 4 plus 9k square is equal to L square, or we have h square upon 4 plus k square is equal to L square upon 9. So if this hk point is moving, so let us call this hk point as xy point. because this is a moving point. So we have the relation x square upon 4 plus y square is equal to L square upon 9. So this is the locus of the point which divides the line in that ratio 2:1. So this is an equation of an ellipse. You all know that. Okay. So this is the concept of locus, and in this way we solve the problem of locus. Okay. So moving forward, straight line. Let us look. Let us have some idea on straight line. What is a straight line? How can we write the equation of a straight line in various form? And what is the slope of a straight line? Any equation of first degree of the form ax plus by plus c is equal to 0, where a, b and c are of course real numbers. A, b, c belongs to real number. Okay, so this equation is the equation of a straight line. Straight line. Okay, what is the slope? What is the slope of a straight line? Slope of a straight line. Say this is a straight line. Okay, slope of a straight line is defined as an angle, tan of angle, which is between straight line and x-axis in positive direction. Positive direction is the rotation in anti-clockwise direction. So this is x-axis, this is y-axis, and this is line. Angle made between x-axis and line in positive direction, that is this angle theta. So slope m means slope, is tan theta. Slope is defined as tan theta. Okay. Now we will be looking at the equation of a straight line in various forms. Slope intercept form. Okay, so a straight line having a slope m, okay, m as a slope, and intercept on y-axis as a c. That means this length is c, 0c. So the equation of a straight line can be written as form of y is equal to mx plus c. Okay, then slope point form. This straight line having a slope m and passing through a point x1 y1. Okay, then its equation can be written in a form of y minus y1 is equal to m x minus x1. Okay, axis intercept form. That is, it has axis intercepts as a and b. This is a0 and this is 0b. Then its equation can be written in a form of x by a plus y by b is equal to 1. 2-point form. That is a straight line passing from these 2 points x1 y1 and x2 y2. So one can find first slope of this line passing through this 2 point, that is slope can be given as y2 minus y1 upon x2 minus x1. Okay, slope of a line passing from these 2 points, and hence we can write the equation y minus y1 is equal to m, which is nothing but y2 minus y1 upon x2 minus x1 times x minus x1. And from origin we draw a normal whose length is equal to p, and which makes angle alpha with positive direction of x-axis. So we can have the equation of line L as x cos alpha plus y sin alpha is equal to p. So this is the normal form. And finally, last, parametric form. Okay. The equation in parametric form means we will be writing the moving point. See, what is the variable here? The variable here is x and y. In any coordinate geometry problem, that is locus. Everything is locus, that is geometry. So there is a relation between y and x, right? So x and y coordinate is moving point. Any point is a moving point which form a locus, which form a geometry. So if we write the value of the coordinates of x and y in terms of some parameter, some another defined variable which can be termed as parameter, so that is the equation in parametric form. Say in a straight line, say this is a straight line. Okay, we have one fixed point, say x1 y1, and a moving point, say xy. Okay, and say we have a parameter r which denotes the distance between these 2 points. Okay, so this xy moves, this r changes. So as xy moves, this r changes, so r is also a variable. Okay, so this x can be written in terms of x1 y1 and r as x is equal to x1 plus r cos theta, and y is equal to y1 plus r sin theta. What is theta? Theta is tan inverse of slope, that is angle made by line and x-axis in positive direction. Okay, that is tan theta is slope, basically the slope. So we can write x minus x1 upon cos theta is equal to y minus y1 upon sin theta is equal to that defined parameter variable r, right? So this is the equation in parametric form. So we have the all equations. We have the equation of straight line in different form, that is slope intercept form, slope point form, axis intercept form, 2 point form, normal form, and parametric form. So basically straight line is formed if we know 2 points passing through the straight line, which that means 2 point defines a straight line. So if we calculate those 2 points from which straight line is passing, we have the equation of that straight line, right? So all forms are basically the same. Okay, so we will be using these different forms while writing the equation of a straight line. Okay, so let's have another illustration. Given a line 2x minus 3y is plus 5 is equal to 0. Find its slope, intercepts made on x-axis, length of perpendicular from origin, and point on the line which is 2 root 13 from its y-intercept. So we have a line 2x minus 3y is equal to 5. So we can write it as 3y is equal to 2x plus 5, or y is equal to 2 by 3x plus 5 by 3. So comparing it with equation y is equal to mx plus c form, we will be having slope as 2 by 3, this is the slope, and y intercept as 5 by 3, right? Okay. Similarly, if we represent this in a form of x upon a plus y upon b is equal to 1, then we will be getting the intercepts on axis, that is x intercept as well as y intercept. So representing this in form of 2x minus 3y plus 5 is equal to 0, or 2x minus 3y is equal to minus 5, or we have 2x upon minus 5 plus 3y upon 5 is equal to 1, or we can write it as x upon minus 5 by 2 plus y upon 5 by 3 is equal to 1. So we have x intercept as minus 5 by 2 and y intercept as 5 by 3. See, y intercept here also we have got 5 by 3. So x intercept as minus 5 by 2 and y intercept as 5 by 3. Next we have to calculate the length of perpendicular from the origin. That is, if this is a line, then we have to calculate this length of perpendicular p. So we have to now compare this with equation x cos alpha plus y sin alpha is equal to p. The equation of a line is 2x minus 3y plus 5 is equal to 0. 2x minus 3y is equal to minus 5, that is. Okay. So we have to change these coefficients in cos alpha and this coefficient in sin alpha, so that this coefficient will become p. So we can divide it in form of, we can divide it by 2 square plus 3 square under root. So we have 2 upon 2 square plus 3 square under root x minus 3 upon 2 square plus 3 square under root. We are basically normalizing so that these values will be less than 1, so that we can call it as cos alpha, and hence this is sin alpha. Okay, minus 5 upon 2 square plus 3 square under root. So this is 2 square 4, 3 square 9, 13, root 13, 2 upon root 13 x minus plus, let me write as 3 upon root 13 y is equal to minus 5 upon root 13, right? So this is basically minus 2 upon root 13 x plus 3 upon root 13 y is equal to 5 upon root 13. So here cos alpha is minus 2 upon root 13, sin alpha is 3 upon root 13, and p is 5 upon root 13. So hence we got the length of perpendicular from origin, that is 5 upon root 13. Now the last part is to calculate the point on a line which is 2 root 13 from its y intercept. What is y intercept? Y intercept is 5 by 3. Okay. So say this is y intercept 5 by 3, and slope of a line is 2 by 3. Okay. So we have tan theta as 2 by 3. Okay. So this is 5 by 3, and this point is 5 by 3, and we have slope as 2 by 3. So we have to find a point. We have to find the coordinate of a point which is 2 root 13 away from this point. So we will have 2 points, one here and another somewhat here. Okay, xy here as well as here, because this distance will also be 2 root 13 something. So tan theta is 2 by 3. We can have two values of sin theta and as well as cos theta. So tan theta is 2 by 3. So sin theta can be either this is, say this is P, this is B, then H is equal to P square plus B square under root 13, right? So sin theta can be either 2 upon root 13 or minus 2 upon root 13. Similarly, cos theta can be either 3 upon root 13 or minus 3 upon root 13. So we have the equation in parametric form. X minus x1 is equal to x minus x1 upon cos theta is equal to y minus y1 upon sin theta is equal to r. Okay, so here we have x1 y1 as 0, 5 by 3, right, this point. So we have x as simply r cos theta, that is r is 2 root 13 and cos theta can be either 3 upon root 13 or minus 3 upon root 13, plus minus. Okay, so this is root 13 got cancelled, so 3 times 2 6, so x can be plus minus 6. Okay, similarly y is equal to y1 plus r sin theta, so we have 5 by 3 plus minus r is 2 root 13 and sin theta is 2 upon root 13, so that is 5 plus minus 4, which is either 17 by 4 or 5 minus 12 upon 3 minus 7 by 4, right? So we have points xy as 17 by 4 6, which is this point actually, and minus 7 by 4 minus 6, which is opposite to this point. Okay, so these 2 points are actually 2 root 13 distance from y-intercept, which is 0.05 by 3. Okay, so this is in this way we can apply our concepts of a straight line. So let's have some more formulas. That is distance of a point from a line. Say this is a line L whose equation is ax plus by plus c is equal to 0, and this is a point, say P, x1 y1. Okay, and we have to find distance between this point P and this line L. So let us denote this distance by d. Okay, so what is this distance d? D can be written in form of ax1 plus by1 plus c upon a square plus b square under root. Modulus of that, we have to take the positive value of this number. Okay, so this, using this formula we can find the distance between point and a line. Distance between two parallel lines. We have two lines which are parallel. If two lines are non-parallel, then they will intersect and their distance is 0. The mutual distance is 0. And if two lines are parallel, then we have a distance d between them. And we can write the equation of two parallel lines like, say this, if its equation is y is equal to mx plus c1, then m is common in both, so its equation is y is equal to mx plus c2. Okay, so this distance d can be written in terms of c1 and c2. c1 minus c2 upon 1 plus m square under root, modulus of that. Okay, so these are some formulas to calculate the distance between two lines and two parallel lines and distance from a point and a line. Okay, equation of a line passing through the point of intersection of two lines. So we have two lines, say L1 and L2, intersecting at point say O, and we have to find the equation of a line which is passing through this point. So there can be infinite lines, right? Okay, because from a given point more infinite lines can be passed. Okay, so we have many points. So equation of this line can be written in term of one parameter, say lambda L1 plus lambda L2, L1 plus lambda L2 is equal to 0. Okay, so if say equation of L1 is given by a1x plus b1y plus c1 is equal to 0, and equation of L2 is given by a2x plus b2y plus c2 is equal to 0. Then equation of line L, which is passing through the point of intersection of this two lines L1 and L2, that is O, can be written in a form of a1x plus b1y plus c1 plus lambda times a2x plus b2y plus c2 is equal to 0. Okay, because this point O will satisfy this equation 2, as this is 0 and this is 0. Okay, so now we will be moving forward and looking on angle bisector, equation of angle bisector. Okay, before that, let us also look on the formula of angle between two lines. We have said two lines, this L1 and L2, whose equations are y is equal to m1x plus c1 and y is equal to m2x plus c2. So we have angle between these two lines as theta, okay, or phi minus theta. Okay, one angle is theta, then other is phi minus theta. So this theta can be written as tan inverse m1 minus m2 upon 1 plus m1 m2. Okay, so if we take modulus, then this quantity is positive and we will be getting acute angle. Okay, smaller angle between these two lines, and subtracting this theta from pi, we will be getting obtuse angle. So this is the angle between two lines. Now we will be looking how to find the equation of angle bisectors. Okay, that is, if we have two straight lines L1 whose equation is a1x plus b1y plus c1 is equal to 0, and L2 the equation is a2x plus b2y plus c2 is equal to 0, then there are two angle bisector, one bisecting this angle and another bisecting this angle. Okay, okay, so if we want to write the equation of this angle bisector, say, let us name this point P, moving point, as xy. Okay, so this point P have equidistance from these both lines. Okay, that is L1 and L2. So distance of point P from line L1 can be written in a form of A1. Let us denote this as HK. So this distance can be written as A1H plus B1K plus C upon A square plus B square under root modulus. And this distance, that means distance of P from L2. This is the distance this is the distance P, say this is N, Pn, and if it is M, then Pm can be written as A2H plus B2K plus C2 upon A2 square plus B2 square under root. This is Pm. So Pn is always equal to Pm. So we have this is equal to this, or we can write as A1H plus B1K plus C upon root under A1 square plus B1 square is equal to plus minus A2H plus B2K plus C2 upon A2 square plus B2 square under root. Okay, replacing this H and K, since this is a moving point, so we can replace this H and K by X and Y. We have the equation of angle bisectors as A1X plus B1Y plus C1 upon A1 square plus B1 square under root is equal to plus minus A2X plus B2Y plus C2 upon A2 square plus B2 square under root. So by plus we will be getting one equation, and by minus we will be getting another equation. So we have this equation of these angle bisectors. So one is the bisector of acute angle and another is a bisector of obtuse angle. So we have to see which one is the bisector of acute and which one is the bisector of acute. Okay. For example, say if we have, let us take an illustration. We have two straight lines, 4x plus 3y minus 6 is equal to 0 and 5x plus 12y plus 9 is equal to 0, and we have to find the angle bisector, that is and we have to also find bisector of obtuse angle and bisector of acute angle. That is, angle bisector we have to find and tell which one is the bisector of obtuse angle and which one is the bisector of acute angle. So we have two lines. Say this line is 4x plus 3y minus 6 is equal to 0, and this line is 5x plus 12y plus 9 is equal to 0, and this is obtuse angle bisector and this is acute angle bisector. Okay, so let's have the angle bisector relation, that is 4x plus 3y minus 6 upon 4 square plus 3 square is equal to 5x plus 12y plus 9 upon plus minus 5 square plus 12 square under root. So this is the equation of angle bisector, and we will be getting two equations, one from plus and one from minus, other from minus, and the two equations are 9x minus 7y minus 41 is equal to 0. Okay, and 7x plus 9y minus 3 is equal to 0. Okay, so these are angle bisectors. So we have to check which one is acute angle bisector and which one is obtuse angle bisector. So let us take this line. Okay, 9x minus 7y minus 41. So let us take this line and let us take this line, 4x plus 3y minus 6 is equal to 0. Okay, and let us find this angle theta between them. So slope of 9x minus 7y minus 41 is equal to 0. Slope of this line is 9 by 7, right? And slope of this line, that is 4x plus 3y minus 6 is equal to 0, is minus 4 upon 3. So we have this angle theta as, this theta is acute angle. Okay, so we have this angle theta as tan inverse m1 minus m2 upon 1 plus m1 m2, right? Which is equal to tan inverse 11 upon 3. Okay, you will be putting this value and you will be getting this 11 upon 3. So this 11 upon 3, of course this quantity 11 upon 3 is greater than 1, right? Isn't it? So this angle is, that means this theta must be greater than 45 degree. Okay, because tan 45 is 1, and after that tan 60 root 3 greater than 1, tan 90 that is infinite, and before 45 tan 31 by root 3 which is less than 1. So theta is greater than 45 degree. So this angle is greater than 45 degree. That means that, which means that this line, this 2 theta is greater than 90 degree. So we have, say, this is angle theta. Okay, so this whole angle, that is angle between 5x minus plus 12y plus 9 and 4x plus 3y minus 6 is 2 theta. So this whole angle is 2 theta. Okay, so this 2 theta is greater than, since this theta is greater than 45, so this 2 theta is greater than 90. That means this line is an obtuse angle bisector. That is 9x minus 7y minus 41 is an obtuse angle bisector. Okay, so 9x minus 7y minus 41, this is equal to 0, is obtuse angle bisector. And the another one is 7x plus 9y minus 3 is equal to 0 is acute angle bisector. So in this way we can find the obtuse angle bisector and acute angle bisector distinctly. Okay, so we have briefly covered the theory with some illustrations of this basic coordinate geometry and straight line. Now we will be handling some problems and also looking on some concepts whenever required.